In this video, I'm going to go through the worksheet for the Chapter 8 test. So please, as you're going through and watching this, pause it to work out some of the problems, or if you already have some finished and you're confident with your answers, you can go through and fast forward to a future question. So for the first problem, we know a couple things about this polynomial. First of all, it bounces off the x-axis at -4, so if I label -4 over here, and then it also crosses the axis at 0, 0, so I know I have an x-intercept there. So those are both x-intercepts. If it bounces, that means that's going to be a double root. So I'm going to have the factor of x plus 4, which would give me -4 as my root, but it is going to be squared. 0, 0 means I'm going to have the factor of just x. So this is going to be a third-degree polynomial at a minimum. So I need to figure out the orientation, and I'm going to figure that out in just a minute, but I also know that it's going to have a point 218, so there's going to be a point somewhere up here. So with this problem, using the point 218, I'm going to put an a value in for a stretch factor, and y equals the polynomial. So putting in the coordinate point 18 for y and 2 for x, when I put in 2 to the second set of parentheses, I would get 6 squared. So I have 18 equals, this right here is 36 times 2 will be 72. And now when I divide by 72 on both sides, I get a to end up equaling 1/4. So that's going to be my stretch factor. And showing my work, yes, that's my work right there for it. That also means if my stretch factor is positive, I know that it's going to be a positive orientation. Another way that I could have figured out positive orientation from this is because if I have no more x-intercepts over here, that means it's got to be going up at that point. So I could have figured that out beforehand, but I wanted to solve for the a value first. So my equation then is going to be y equals 1/4 x plus 4 squared. Now, making a sketch of this graph, if it is a third-degree polynomial, it is going to end with the arrow on the right up, which means it starts with the arrow on the left down. So it's going to go to this intercept and bounce, and then it'll go through and then go up. And let's just say that that point touches over there. There we go. And there's a graph and sketch and answered all the questions. Let's go on to problem 2. Okay, so for this one, 3 different parts. Part A is the only one that needs to actually look the same as I have it. B and C, you could have different versions, and I'll talk briefly about those. So when I look at this equation right here, it is going to be a 4th-degree polynomial with positive orientation. That means both arrows are going to be pointing up. I also will have intercepts at -3 from this factor, +2 from this factor, and that one's going to bounce because it's squared, and +5 from that factor. So knowing that it starts up and it's going to go through at -3 because x plus 3 is the factor and it's a linear factor. It's then going to bounce at 2 because that linear factor is squared, making the double root. And it's going to go through that linear factor of x minus 5. The last thing I need to do, I've stated my x-intercepts. They were, again, -3, 2, and 5. But now my y-intercept, I'm going to put 0 in for all of my x values. So y is going to equal 3, -2 squared, and -5. So that's going to be 3 times +4 times -5, which will then be a -60. So labeling that, it is going to be -60. So I've now stated the x and y intercepts and gave a sketch. Problem B. Also a 4th-degree polynomial, But this one now has negative orientation. So instead of looking like a W like the last one, this is going to look more like an M. It also has 2 real and 2 complex roots. 2 real roots means that it's going to touch the x-axis in 2 spots, or it would have a double root, but it doesn't specifically state a double root. So I'm just going to draw it so that my x-axis is going to touch it twice. Now I could have an x-axis move down. This would be 4 real. You could also have 2 real like this. So what I'm going to do for my sketch is, I know the arrows are pointing down, intersect, intersect, and do that. That is one possibility. But there are many possibilities, as long as it only intersects twice and then it has some other sort of curve in it where it does not touch the x-axis again. Problem C. So it's a 50-degree polynomial with positive orientation. That means my right arrow is going to face up, my left arrow is going to face down. Now with a 50 degree, it's going to have 5 direction changes. So that's a possibility. However, this one's going to have 2 complex roots. So just like in the last one, there's going to have to be some direction changes or humps here where it's not going to touch the x-axis. And the other part with this one is that it has a triple root. So if you think of a triple root, if this is my x-axis, a triple root means it's going to go through that x-axis and look like a cubic. That's going to be a triple root. So knowing that starting down and ending up, and knowing that when it touches the x-axis, I have a triple root, a possible looking graph would be something like that. A triple root goes through like that, and then we have our 2 complex roots over there. Looking at problem 3. Problem 3a, I want to state all of the roots. I also want to figure out all the factors for this one. Normally we go through first and list our possible factors of negative 102. There's going to be a few of those, so I'm actually going to go straight to the step right now of graphing it with the calculator. And when you look at a graphing calculator, if you haven't yet, I'd pause it and take a look at the graphing calculator. When you look at your graphing calculator, the graph looks something like this, with that being at 6. You can double check that on your table, and that is the 0.60. So I know for sure that that is an integer root. So with another curve over here, that means we're going to have 2 complex roots, which means when I write my factors, I'm going to have a linear factor from this one, and I'll have a quadratic factor from those. So again, looking at the fact that I have 6 as a root, that means I have x minus 6 as a factor. So I'm going to do my polynomial division with x minus 6. If you have not done that, pause it now. All right, so I have x cubed. That means up top I have x squared, and then this is a negative 6x squared. These terms here have to add up to negative 14x squared, so this has to be a negative 8x squared, which means up top I get negative 8x, which makes this positive 48x. These two have to add up to 65x, meaning this one's a 17x, and it's plus 17 up top. And multiplying through, I get a negative 102. That works out. So x minus 6 was one factor. This is my other factor, x squared minus 8x plus 17. To figure out my roots, I now do zero product property with my factors. X minus 6 equals 0. Well, we already got this one actually from the graphing calculator, and it was 6. So I have a root of 6. The other one is the x squared minus 8x plus 17 equals 0. And now I need to solve this quadratic. I could use the quadratic formula. I could complete the square. Either of those will work. I will not be able to factor this one. So factoring in zero product property is not an option. So if I go through, I'm just going to do the quadratic formula. I get x equals the opposite of b, which is a positive 8, plus or minus square root of negative 8 squared, minus 4 times 1 times 17, divided by 2 times 1. So I get 8 plus or minus the square root of 64 minus 68 over 2. That gives me 8 plus or minus the square root of negative 4 over 2, which is going to be 8 plus or minus 2i over 2. And now since both terms of my numerator I can divide by the denominator of 2, I can simplify this. So 8 plus or minus 2i over 2 will equal 4 plus or minus I. So that was my other two roots. So my roots are 6, 4 plus I, and 4 minus I. I could write it like this as well, doesn't matter. Those are the three roots for the third degree polynomial. Problem B. Remember that when we're dealing with sine and cosine graphs, the a value, the b value, and the k value do not change. So it doesn't matter if I'm doing a sine, cosine, positive sine, or negative sine, positive cosine, negative cosine, it doesn't matter. These values do not change. So those are always the values I want to figure out first. I know that this goes up to a top of 3 and the bottom is negative 7. That right there is a change of 10. So halfway between positive 3 and negative 7 is my midline. So the k value is negative 2, which makes my amplitude 5. Looking at my b value then, I want to look at a distance of 2 pi. So if I just go from negative pi over here to positive pi, that's a distance of 2 pi. And from here, that means it goes 1 and 2 full cycles. If there are 2 full cycles in that distance of 2 pi, that means the b value then is 2, because your b values are number of cycles in 2 pi. Not that you need it for this problem, but remember that the period is 2 pi over b, which would be 2 pi over 2. So the period for this equation would be pi. Once I have that information, now I need to figure out a locator point. One of the easier ones to go with is that one down there, because that is right on my y-axis, which means my h value is 0. If you start from the bottom, it is a negative cosine graph. So if it's a negative cosine, I have a negative, and then 5 cosine 2x, because I do not have an h value, and then minus 2. Notice that the k value, the a value, and the b value are all the same there. I could pick another possibility. Starting on the midline, going up is a positive sine graph. So the equation using the red dot there as my locator point would be y equals, this is a positive sign, so it's positive 5 sine 2, and now x minus my h value. Well, the h value now is halfway between 0 and 2 pi, or pi over 2. So that is going to be an h value of pi over 4 minus 2. Again, noticing that my k value, the a value, and the b value have again stayed the same. Now, there are other possibilities you could go with. You could pick this as your locator point. That would be a positive cosine, and your h value would be pi over 2. You could pick that spot. That would be a negative sign, and you would just need to figure out your h value. You could pick any one of these other values here as h values, but the easiest ones are probably the two that I just did right there. And granted, you could pick values over here as well. On to problem 4. So if we're looking at this equation, this is at minimum a 4th degree polynomial with negative orientation. I have x-intercepts at -5, -3, and +5. The one at +5, which would be the factor x minus 5, bounces, so that one has to be squared. I have factors of x plus 5 from that root and x plus 3 from that root. So my equation will be y equals some a value, and my a value is going to have to stretch it or compress it so it goes through that coordinate point. So some a value times x plus 5 times x plus 3 times x minus 5 squared. Now using that coordinate point, I'm going to put in -25 for my y value, a, and then I'm going to put in 0 for my x values. So from here I'm going to get 0 plus 5, 0 plus 3, and 0 minus 5 squared. So I have -25 equals a times 5 times 3 times 25. Solving this by hand, divide both sides by 25 and get rid of that. So I have a -1 equals 15a, so a equals a -1/15. You could use a calculator to do that as well, but your a value is -1/15. That means I now go back to my original problem in purple here, and I'm going to replace that a value with a -1/15. And there's my equation. Something to be careful with here. When you're going through, you know that this problem should have negative orientation because that right arrow is down. I suggest not trying to make this a value negative. Instead, just go through and solve it like you normally would, and the a value should come out negative. If it doesn't, then you know you maybe did a mistake somewhere. On to the next part of problem 4. We're dealing with a cubic function that has these roots. So 4 plus or minus 8i means I'm going to have a quadratic factor, and 2 is going to give me a linear factor. That's going to be x minus 2 is that linear factor. So to figure out the quadratic that one comes from, I suggest if you're not sure on how to do that, go back and look at videos from 8-84 or 8-85. 8-85 has us working backwards, and that's the method I'm going to show here. So if 4 plus or minus 8i is a root, that means x equals 4 plus or minus 8i. Now, I don't necessarily need both the positive and negative, so I'm just going to pick one of them. I'm going to use the positive. It doesn't make a difference. To work backwards, I'm going to move the 4 to the other side and get x minus 4 equals 8i. I'm then going to square both sides. And the reason why I want to square is because I want to get rid of the imaginary number. So when I square both sides, x minus 4 squared is x squared minus 8x plus 16. When I square 8i, 8 squared is 64. I squared is -1, so it is -64. Solving now to get the 64 moved to the other side. I'm going to add 64 to both sides, and I get x squared minus 8x plus 80 equals 0. And if I would go through and start off with this problem, if you would do completing the square, you would end up with that because of the steps going backwards. If you do quadratic formula, that is how we get these roots. So that is the quadratic that gives us those roots. Now, how do I get my cubic? Is I take these two factors and multiply them together. So I'm going to just use a generic rectangle. I have an x minus 2, x squared minus 8x plus 80. So I get an x cubed, negative 2x squared, negative 8x squared, positive 16x, positive 80x, negative 160. So my cubic in standard form now is going to be x cubed, or y equals x cubed minus 10x squared plus 96x minus 160. The next part of this problem is asking if there are any x-intercepts. And I do know that there's going to be one x-intercept because this root right here of 2 is an x-intercept. That is a complex root, which means it does not touch the x-axis. So there is one real one at x equals 2. Going on to the next problem. All right, the very first one, I'm going to work on problem A first. To solve an absolute value, I want to get the absolute value here by itself. So the first thing I'm going to do is subtract the 4 from both sides. After that, divide everything by the negative 3, and I get positive 4 equals the absolute value of x minus 7. From here, what I'm going to do is take the stuff inside the absolute value, and the x minus 7 could equal 4, or that x minus 7, if I find a value of x that makes it equal negative 4, then the absolute value of that will still make it then equal 4. So these are the two side problems that I have. X minus 7 equals 4, and x minus 7 equals negative 4. So adding 7, I get 11 for that part, and I get 3. So those are the two solutions for that problem. Problem B, it's a logarithm, base 6 of 2x minus 8 equals 3. So I'm going to solve this one by first of all writing in exponential form. That is base of 6 for the log, so it's base of 6 for the exponential. My exponent is what the logarithm equals. So 6 to the third equals what I'm taking the log of, 2x minus 8. Now, I can just simplify this here. 6 to the third is 216. Add the 8 to both sides, I get 224. And divide, I get 112. Taking a look at problem C. So on this one, before I want to square both sides to get rid of the square root, I want to subtract 4. So now I have the square root of 2x minus 5 equals x minus 4. Now I'm going to square both sides. So I have 2x minus 5 equals x squared minus 8x plus 16. Solving this quadratic, it equals 0. So 0 will now equal x squared minus 10x. And adding 5 to both sides, I'm going to get plus 21. That is going to factor into x minus 3 and x minus 7. Using zero product property, I get x to equal 3 and 7. But before we go any further, I want to double check a couple things. Whenever we have a square root function with an x on the other side, we always want to look for extraneous solutions. So substituting in 3, I'm going to have 4 plus square root of 6 minus 5, which is going to be 4 plus square root of 1, which is now 5. That does not equal, when I put in 3 on the other side, so 3 is extraneous. If I do that same problem, but now I use 7, I'm going to get 4 plus the square root of 14 minus 5 is 9. So I have 4 plus and square root of 9, which is 4 plus 3, and 7 does equal 7. That works out. So my answer is just 7. 3 is extraneous. Problem D. First thing I need to do here is move the 24 over, get this quadratic equal to 0. So I have x squared minus 10x minus 24 equals 0. That's going to factor into factors of negative 24 that add up to negative 10 are going to be x minus 12 and x plus 2. Zero product property gives me 12 and negative 2. Problem E. This is also going to be a logarithm problem because my exponent is the variable. But before I do that, I need to get the base and the exponent by themselves. So the first step is subtract the 5 from both sides, giving me 3, 2.5 to the x, equals 18. Divide both sides by 3, and I get 2.5 to the x equals 6. This is where the logarithms come in. I now take the log of both sides. The power property of logarithms says that I can take this x value right here, and when I take the log of that side, it comes out and becomes multiplying my log of 2.5. Since I use the logarithm, whatever base I want, I'm using base 10, so I can use my calculator. So I divide both sides by log of base 10 of 2.5. That's a giant 1. So I now have x equals, and you use your calculator to figure out that one. And that becomes approximately 1.955. On to problem F. Okay, another quadratic, but on this one, I am not going to set it equal to 0. Since it's already in perfect square form, I'm just going to move the 9 to the other side by subtracting it, and I'm going to get x minus 4 squared equals negative 4. Now when I take the square root of both sides, I get an x minus 4 equals, square root of negative 4 is going to be 2i, but don't forget about the plus or minus on this problem. And adding 4 to both sides to get x by itself, I get 4 plus or minus 2i. On to problem 6. Finding the inverse. Remember that f of x is the same thing as a y value, so I'm going to switch my x and y's and solve for y. So now I have x equals 4 times the cube root, y plus 1 minus 7. First thing I need to do is get rid of this negative 7, move that to the other side. So I have x plus 7 equals 4 times the cube root of of y plus 1. Dividing both sides by 4. Those cancel out, so now I have x plus 7 over 4 equals the cube root of y plus 1. Now it's important to notice the order that I'm doing things, because at this point, I now need to cube to undo the cube root. But I'm now cubing everything on this side, so I need to make sure I have parentheses. and I'm cubing the x plus 7 over 4. So now I have y plus 1 equals x plus 7 over 4 quantity cubed. Moving the 1 to the other side, I get y to equal x plus 7 over 4 quantity cubed minus 1. Since this starts off with an f of x, I want to use my function notation, which is here, so I replace the y again with my function notation, and my answer then is x plus 7 over 4 cubed minus 1. So the next part is domain and range. So this is a cubic function. So if it's a cubic function, it's going to look something like that. So the domain is going to be all real numbers, so negative infinity, less than x, which is less than infinity. And the range is the same thing. Negative infinity is less than y, which is less than infinity. On to the last problem. So we have a sequence. We want to first of all write an equation for it, and then figure out if this is a term. Well, the sequence right now is changing by -4. So to write my equation, it's going to be a -4n, but then I need to figure out what is my zero term. What's my zero term over here if I go backwards? So I would add 4 and get 35. That is my t of n equation. Now, if I want to figure out if this is a term, I'm going to take -313, and I'm going to substitute in for t of n, and see what my n value is, because the n value is your term number, and see if that works out. For it to work, n has to be a positive integer. It cannot be a decimal, and it cannot be negative, because sequences do not have decimals for inputs, and they do not have negatives for inputs. So it needs to be a positive integer. So solving for n, subtract the 35. I get -348 equals -4n, and when I divide by -4, I have n to equal 87, which means that yes, it is part of the sequence. It is the 87th term. Best of luck on the test.